I'll redraw the diagram. Okay, P naught, V naught, gamma. This is a heater coil. Okay, this is that piston. Huh? Okay, I'll take it out, the diagram. Okay, read it now. Two rectangular boxes shown as a partition which can slide without friction along the length of the box. Initially, each of the chamber box has 1 mole of monoatomic gas. 1 mole is telling, so there's a 1 mole. Let me write it. Monoatomic gas means gamma 5/3. At a pressure P naught, V naught, and temperature T naught. The chamber on the left is slowly heated by an electric heater. This is a heater coil. The wall of the box and the partitions are thermally insulated. The gas in left chamber expands, pushing the partition until the final pressure in both the chambers will become 24 to 43 P naught by 32. Okay, something I'm showing it. The partition is being pushed. The pressure in both the chambers, 243 P naught by 32, 243 P naught by 32. Okay, fine. This is final temperature of the gas in the chambers. The work done by gas in the right chamber, or temperature of the gas. Yeah, it is. Okay, this one. So final temperature, let me call this as T2 chamber. This is T1. These are the final pressures. What is the volume? V1 and V2. Okay, let's do one thing. What process the gas is undergoing in each part? Piston is non-conducting. Piston is non-conducting. And the cylinder is also non-conducting. So first look at this. And look at this one. It will accept energy, no? So there is what happens, some heat is absorbed by the gas in the left part. Then what it does after absorbing it, temperature of that will increase, pressure will increase, volume will increase. So it will expand. So what process? Pressure constant? No. Volume constant? No. Temperature constant? No. What process it can be? Anybody?
Isobaric, sir.
Adiabatic, sir.
Okay, isobaric. Isobaric process, what happened to pressure? P naught, 243 P naught by 32.
No, sir.
Okay, pressure not there. Okay, no. Somebody said adiabatic. Huh? In adiabatic process, heat is absorbed. No, yeah. The heater coil supplies heat.
The general process, sir.
It's very important. You should identify what actually going on. If you don't know what actually going on, we can't write any equation. Are you please try to understand? Your teacher is telling you to think, you have to think. That's all, or no other way. You have to first analyze. Okay, no, so general thermodynamic process, fine. Any reason for that? Because it's quite clear, no, pressure is increasing, heat is absorbed. It's telling the piston is shifted towards right, volume expanding, So volume changing. So volume changes cannot be isochoric, temperature varies cannot be isothermal, pressure varies cannot be isobaric, heat is absorbed cannot be adiabatic. So general thermodynamic process. Now, what about the gas in the right part? Non-conducting piston, non-conducting cylinder. Cylinder is also insulated. Yeah, now, what can be this process? You must answer this. There's no other way. Huh? Anybody? Adiabatic process. Okay, good. Yeah, fine, fine. Huh? It's adiabatic process. The gas will undergo adiabatic process. Getting no this one. Any reason for that? Pressure, temperature, volume, all three are varying, and there's no heat exchange for this gas. No, 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 nowhere the heat is entering. Sir, through piston. What is the piston? Non-conducting. Getting the idea? So himself is telling piston non-conducting. So I think what we have to do, we have to be very extra alert. No, we should look at all the things. No, piston conducting, non-conducting, cylinder conducting, non-conducting. We should make observation of all these things. Then only we can take a decision. Otherwise, not possible. Okay, now we are very sure this will undergo a diabetic process. Okay, now let's get into. He's asking now the temperature of the gas in each part, work done by the gas in the right part. Okay, first, shall we in right part we'll get into in right part. In the right part, shall we use formula for adiabatic process? P1 minus gamma T to power of gamma. Can you remember that formula? Is I'm okay with the formula? For adiabatic process, how pressure and volume temperatures are related. So initial pressure P naught 1 minus gamma. Okay, anyway, like or PV gamma, we can write it. P naught V naught gamma equal to 243 P naught by 32 V2 gamma. Okay, V2 gamma. Do we know gamma S? So from that, what happened? I'll get the V2 in terms of V naught. P naught get cancelled. So here it will be V2 equal to V naught 32 by 243 1 by gamma. Gamma is how much? 5 by 3. Anybody? Gamma 5 by 3, no? So will become 3 by 5. Is that okay? 243, can I write 3 to the power of 5? 32, 2 to the power of 5. Okay, 2 to the power of 5 cancel. So 8 by 27. So V2 equal to 8 V naught by 27. So now I know it. So then after this, what we can do? The temperature also we can calculate. So what is the formula? T2 T naught V naught gamma minus 1 T2 V2 gamma minus 1. So we know V2. Now we know gamma. Okay, get expression for T2. T2 in terms of T naught. So this will be V naught by V2 gamma minus 1. Anybody? T2? Adiabatic process, no? Anybody value? Please help me with value. I'll proceed next.
Sir, 9 by 4 T naught.
9 by 4, sir.
9 by 4. Okay, 9 by 4 T naught. Okay, no, I got T2. I know temperature of the gas in the right chamber. No. What is the work done by the gas in the right chamber? How to get the work done? Because we don't know how that pressure varies. What is work done by gas in adiabatic process? Minus delta U minus N R, or okay, it's a monoatomic gas, no? N3R by 2. Temperature of gas T2 minus T naught. Initial temperature is T naught. Substituting value of T2, we'll get this one. So I think it's a 1 mole, no? 1 mole of gas in each part. Okay, this will be minus 3R by 2, 9 T naught by 4 minus T naught. 4, 5, 15 R T naught by 8. Negative, what do you mean by negative? Volume decreases. Work done by gas. He's asking final temperature of gas in the chambers. In the left chamber, how to calculate the temperature T1. Whose help you are going to take? I think really it's a very good way of testing students. He's asking now to get the temperature of gas in the left chamber. Whose help we have to take it? In the left part, we don't know. Do we know V1? Can we calculate V1? Because we know V2. Can we calculate V1? Anybody? Look at the diagram. Shall I write V1 plus V2
Yes, sir.
equal to 2V naught? V2 is how much? 8V naught by 27. Okay, we'll get V1. 2V naught, 8V naught by 27. 54 minus 8 will be 46 V naught by 27. Okay, this is about V1. I want temperature T1.
Sir, number of moles.
Number of moles will remain same in the left part. Total amount of gas has to remain constant. Finish over there, no other way. With that, what happens? We'll get the temperature of gas in the left part. So let me adjust everything here only. Okay, now in left part. Now I'll write it like this. So P naught, V naught, T naught, it should be equal to 243 P naught by 32 V1 T1. Okay, what we have is, so we know V1, solving that we'll get the T1. What about the heat supplied by the heater coil? Can we calculate heat supply? Not possible here, because we need some information. Or what all heat supplied. So what will happen is like a part of it is converted into increase in intensity of the gas in the left part, work done by the gas in the right part, work done by the gas in the left part. Work done by the gas in the left part have to be determined. Here, in fact, the pressure, here the gas does positive work, this will do negative work. Slowly it will move. So what all we supply it, a part will be converted into rising intensity, remaining work done. Okay, this T1 you calculate, I'll just leave it. I don't have value. No. I just brought a very nice question, sir, where a student has to really 9T/4. It is okay. T1 9T0/4. Let me write it. How come both same?
Sir, it is 217 T naught by 16, sir.
207, sir.
207.
207 T naught by 16.
Not 217.
No, sir.
Okay, check one's answer. I'll go back.
207 only, sir. Sorry, sir.
207. Yeah. Okay, now read this question. It's really very, very, very important. Again, I'm bringing some action agent. Work done by the action agent. Let me give better diagram. Okay, well,